Okay, so good evening, everyone. I start the class now. This is practice sessions. I hope you know what this session is about. Hello, anyone there? This session is about the practice problem solving session on the course of Soil Mechanics Geotechnical Engineering 1. Every Sunday, this course is going to be conducted from 5 to 7. Uh, this is the first week, and the topic of the first week is origin of soil and its classification. Is the PPT visible to everyone? Is the PPT visible to everyone?
Yes, sir.
Yeah. Okay. So I will start the session now. These practice sessions will contain a set of questions. Okay, MCQ, MSQ, true false questions, numericals. Okay, these kind of questions will contain. I will first of all dictate all the questions to you one by one. I'll repeat some questions. You have to write down all the questions. You have to be ready with your copy, pen, and a calculator. If and when required, you have to write down all the questions as I say. And after that, I'll give you some time, most probably around 10-15 minutes on average, to solve those questions. After that, I will again start the presentation and I'll dictate the answers, and it will be an interactive sessions where you can tell me the answers and the explanation. And if you cannot solve the questions, I will tell you the answers and give you the explanations of those questions. Okay, so I'll be starting now. This is the first class. The topic is origin of soil and its classification. Okay, so in this chapter, in this content, we are going to solve some questions about the origin of soil, formation of soil, transportation, deposition, and properties of soil, and classification of soil based on their grain size distribution and plasticity properties, etc. Okay, so this this content has a set of around 20 to 21 questions along with some numericals. So let's start. Okay, you have to write down the questions. Okay, I'm just repeating the questions. The first question is, what is the type of soil formed after deposition in lake water? What is the type of soil formed after deposition in the in lake water? If you have finished writing the question, you can tell me. Okay, I'll just move on to the next question. What is the type of soil formed after deposition in lake water? And your options are alluvial soil, lacustrine soil, colluvial soil, marine soil. Out of these, which type of soil are found by deposition in the lake water? I hope you have written on the question along with the options. I'll go to the next question. A lacustrine deposit with alternate thin layers of silt and clay is called. A lacustrine deposit with alternate thin layers of silt and clay is called. The options are loam, muram, bentonite, and warped clay. I'll repeat the question once. A lacustrine deposit with alternate thin layers of silt and clay is called loam, muram, bentonite, and warped clay. Alternate layers of thin layers of silt and clay. Okay, next question. Which of the following are formed by transportation by gravitational forces? Can you follow the questions, everyone? Hello? Can you follow the questions and my voice? Anyway, which of the following are formed by transportation by gravitational forces? The options are Loess, Till, Laterite, and Tellus. Which of the following are formed by transportation by gravitational forces? The options are Loess, Till, Laterite, and Tellus. Next question. Which of the following type of soil remain at their place of formation? Which of the following type of soil remain at their place of formation? The options are aeolian soil, marine soil, residual soil, and colluvial soil. Which of the following type of soil remain at their place of formation? Aeolian soil, marine soil, residual soil, or colluvial soil? Next question. Which of the following processes may lead to disintegration of rocks? Which of the following processes may lead to disintegration of rocks? The options are chemical, physical, biological, or all of these. Which of the following processes may lead to disintegration of rocks? Chemical, physical, biological, or all of these? Clear? Are you able to follow? Saurav Dighe, Himani Jain. Are you able to follow?
Yes, sir.
Okay. Yes. So, which of the following processes will
Sir,
lead to? Yes. Hello. Hello.
to
Yes.
take chat box.
Chat box. You don't need to answer now. Okay. Don't need to answer now. You write down the questions. I'll give you time to solve. I'll give you time to solve the questions. Okay, and then we'll discuss the answers. It is going to be an interactive session.
Okay,
Okay,
sir.
so no need to write the answers in the chat box. I'm repeating the question so you have to write the question along with the options clearly. You solve the I'll give you time, 10-15 minutes. I'll give you time to solve the questions, and then after that, after the break, we will discuss the answers. Clear?
Okay, sir.
Yeah. Okay. This is a true false question. Soil transported and or formed by different processes are constantly subjected to further change by physical, chemical, or biological actions. I repeat, soil transported and or formed by different processes are constantly subjected to further change by physical, chemical, or biological actions. Is this statement true or false? I'll repeat once. Soil transported and or formed by different processes are constantly subjected to further change by physical, chemical, or biological actions. True or false? Next question. Which of the following processes leads to change in the structure of the rock and not its composition? Which of the following processes leads to change in the structure of the rock and not its composition? Which of the following processes leads to change in the structure of the rock and not its composition? Your options are carbonation, hydrolysis, reduction, abrasion. I hope you know the meanings of the terms in the options. Which of the following processes leads to change in the structure of the rock and not its composition? The options are carbonation, hydrolysis, reduction, and abrasion. Next question. Cohesionless soils are formed due to, options are oxidation of rocks, leaching action of water on rocks, physical disintegration of rocks, or wind action. Cohesionless soils are formed due to oxidation of rocks, leaching action of water on rocks, physical disintegration of rocks, or wind action. Next question. Again, another true false question. Weathering process related to the activities of microorganisms is termed as geochemical weathering. Weathering process related to the activities of microorganisms is termed as geochemical weathering. True or false? Weathering process related to the activities of microorganisms is termed as geochemical weathering. You have to tell me the statement is true or false. Okay, before I go on to the next question, I'll just tell one thing to the ones who have joined late. Okay, those who have joined late, this is the practice problem solving sessions of soil mechanics, geotechnical engineering 1. And I will be taking this session on Sundays 5 to 7. Um, and this will be a set of questions which you are going to solve. I'm going to first dictate all the questions, and right now, as of now, I am dictating the question. You need to write down all the questions, and if you have missed, I will just repeat at the end the first 8 set of questions, and then I will give you some time to solve the questions, and then uh, you can tell me when you have finished. Then we'll discuss all the answers. Okay, for those who have joined late. Okay. Okay. So last question was weathering process related to the activities of microorganisms is termed as geochemical weathering. Statement is true or false. Okay. Next question. Uncemented deposits of mineral and or organic particles covering large portion of the earth's crust is called. Uncemented deposits of mineral and or organic particles covering large portion of the earth's crust is called. The options are rock, loam, soil, or aggregates. I'll repeat the question. Uncemented deposits of mineral and or organic particles covering large portion of the earth's crust is called rock, loam, soil, or aggregates. Yes, Wang Cheng, there is no need to write the answers right now in the chat. I'll give you time. Okay. Uh, in that time, you can solve the questions, and then after that, we are going to discuss the answers. Okay. Okay. Next question. Alluvial deposits at foot of hills of or mountains is known as. Alluvial deposits at foot of hills or mountains is known as. The options are deltaic deposits, loess, estuarine deposits, or Piedmont deposits? Alluvial deposits at foot of hills or mountains. When alluvial soil is deposited near the foot of mountain ranges, then that soil deposit is known as deltaic deposits, loess, estuarine deposits, or Piedmont deposits. Alluvial deposits at foot of hills or mountains. Next question. Okay, so till now, whatever we have covered, the questions were related to the origin of soil, origin and transportation of soil. From slide number 13, from this question, we come to the classification of soils based on their sizes, range and distribution, and based on their composition, based on their grain size distribution and based on their plasticity characteristics or composition. Okay, so next question is, the biggest size of a clay particle is? The biggest size of a clay particle is? The options are 0.003 mm, 0.002 mm, 0.0002 mm, or 0.075 mm. I repeat the question. The biggest size of a clay particle is? What is the biggest size for clay particle? 0.003 mm, 0.002 mm, 0.0002 mm, 0.075 mm. Next question. Silty clay indicates. I'm asking about the meaning, the significance of the classification of silty clay. Silty clay indicates, option 1, silt percentage is less than that of clay. Option 2, silt and clay particles are in equal proportion. Option 3, silt percentage is more than that of clay. And option 4, none of these. Silty clay indicates silt percentage is less than that of clay. Silt and clay particles are in equal proportion. Silt percentage is more than that of clay, or none of these. Next question. BIS soil classification is based on? I hope you know the meaning of BIS. Anyone knows what BIS means? Anyone knows what BIS means? BIS means Bureau of Indian Standards. Okay. The meaning of BIS is Bureau of Indian Standards. So BIS soil classification, it is soil classification based on the Bureau of Indian Standards. It is primarily based on which properties of soil? Okay, the options are grain size distribution, plasticity properties, both of the above, or none of the above. None of these. You can also tell me if there is something else required for the classification system in BIS, but the primary options which have been given over here, either any one or both or none of these are responsible for taking part in the BIS soil classification. So I'll repeat the question once. BIS soil classification is based on BIS soil classification is based on, the options are grain size distribution, plasticity properties, both of the above, or none of these. Alright, I'll go to the next question. Boundary classification is to be resorted for coarse grained soils when the percentage fines is, I repeat, boundary classification is to be resorted for coarse grained soils when the percentage of fines is, your options are greater than 12 percentage, less than 5 percentage, between 5 percentage and 12 percentage, or none of these. Boundary classification, I hope you know the meaning of boundary classification. It is when the percentage of fines is small but not insignificant, so that we cannot ignore the percentage of fines in its nomenclature. So that particular classification is resorted when the percentage of fines lies greater than 12%, less than 5%, between 5 and 12%, or none of the options. Okay. Next question. Among the given soils, the specific surface is the highest for. Do you know what specific surface means? Anyone? Okay. Specific surface, it means surface area per unit mass. Okay. If you take one particular soil sample and I want to find out the surface area, then that surface area which I have calculated, that surface area divided by the mass of the sample. Surface area divided by the mass of the sample will give me the specific surface area or specific surface, whatever. Okay, so that is what is called the specific surface. So in this question I'm asking about the specific surface. So which of these soils, sand, silt, gravel, or clay, will have the maximum specific surface? That is, for a for less magnitude of mass, it will have more magnitude of surface area. Okay, that is the main concept of specific surface. So among the given soils, the specific surface is the highest for The options are sand, silt, gravel, and clay. You have two fine grained soils and two coarse grained soils over here. You have to give the answer the same. Okay. Okay. Next question. The soils which plot above the A line in the plasticity chart are. Do you know what is the plasticity chart? Anyone? Okay, I'll come to the plasticity chart later. I have given the diagram of plasticity chart over here. As of now, just write down the question. The soils which plot above the A line in the plasticity chart. It is this chart. It has plasticity index on the y-axis and liquid limit on the x-axis. So, which plot above the A line? This is the A line. Which plot above the A line? What are those soils called? What is the general classification, generalized classification of those type of soils? Your options are inorganic clay, silt, organic clay, or organic soil. It will become clear as and when I show you the chart. So no need to worry about that. It is just very much identifiable from the chart, the diagram of the chart itself. So I'll repeat the question. The soils which plot above the A line in the plasticity chart are, the options are inorganic clay, silts, organic clay, or organic soil. Clear? Okay. Next question. A soil has liquid limit of 20% and plastic limit of 14%. As per IS, that is Indian Standard Classification, the soil is. Write down the data very carefully. The soil has a liquid limit of 20% and plastic limit of 14%. Okay, so in both the questions, the previous one and this one, you have to use this chart. It is given over here, liquid limit of 20% and plastic limit of 14%. So as per this given data, how will you classify the soil? So the options are inorganic silts with high plasticity, organic clays of medium to high plasticity, inorganic clays and silts of low plasticity, and inorganic clays of medium plasticity. The soil has a liquid limit of 20% and plastic limit of 14%. As per the IS classification, that is the plasticity chart given by the Indian classification system, the soil will be inorganic silts with high plasticity, organic clays of medium to high plasticity, inorganic clays and silts of low plasticity, or organic clays of medium plasticity. Okay, this is the plasticity chart as per the IS classification system, and you have to use this one while giving the answers of the previous two questions. Okay, and you have to remember this equation of the A line because we have a question with that also. Next question, another true false true false statement. If the soil retained on 75 micron sieve is more than 50 percentage, if the soil retained on 75 micron sieve is more than 50 percentage, the soil is fine grained. the soil retained on 75 micron sieve is more than 50 percentage, the soil is fine grained. You have to tell me the statement is true or false. Okay, some people have joined late. You just write down the questions first. Okay. Okay, for those who are joining late, this session is scheduled from 5 p.m. onwards. On every Sunday, this session is scheduled from 5 p.m. onwards. Uh, as of now, those who have missed the set of questions, I will be just a moment. Yes, this session is scheduled from 5 to 7. So those who have joined late, please write down the questions first. I will just repeat some set of questions. You're going to write the questions. I'll give you some time to solve those questions, and then after 10-15 minutes, we'll be discussing all the answers. Okay. Okay, write down from this question. This is a true false statement. If the soil retained on 75 micron sieve is more than, just a minute. Yes, the soil retained on 75 micron sieve is more than 50%. The soil is fine grained. Is this statement true or false? Next question. A soil has liquid limit of 30%. The corresponding plasticity index given by the A line is, I had shown you previously the equation of the A line here. So using the equation of the A line, you have to answer this question and find out the plasticity index. So this is, you can say, another way of finding out the plasticity index if you know the liquid limit only. If the soil corresponds to the A line of the plasticity chart, because the equation of the A line is the one which I have shown in the diagram. So you have to remember the equation and solve this question. A soil has a liquid limit of 30%. The corresponding plasticity index given by the A line is, the options are 14.6, 7.35, 7.30 or 9.3. A soil has a liquid limit of 30%. The corresponding plasticity index given by the A line is 14.6, 7.35, 7.30, 9.3. The next question, this is the last question. Yes. Group index of soil ranges such that, GI, there is a group index will be always less than 20. Group index will be between 0 and 20, excluding 0 and 20. Group index will be between 0 and 20, including the values of 0 and 20. Or group index will be always less than 15. I hope you know what group index is. The HRB classification system. That group index will always be lying between some values, or will be always more than a particular value, or will be always less than a particular value. Okay, so that rule is being asked in this question. How is the group index of soil ranged? Is it always less than 20? Is it always less than 20? Is it between 0 and 20, neglecting the values? Is it between 0 and 20, including the values 0 and 20? Is it always less than 15? Clear? I hope it is clear, and I hope you have all written down all the questions. I'll just go through the first few set of questions for those who have joined late. What is the type of soil formed after deposition in lake water? Alluvial soil, lacustrine soil, colluvial soil, or marine soil? This you just have to remember the deposition in the lake water, and then you just write down the answer. A lacustrine deposit with alternate thin layers of silt and clay. Here, alternate thin layers of silt and clay is the main theme of the question. What is the type of soil? Is it loam or muram or bentonite or barred clay? Okay. Next question was, which of the following are formed by transportation by gravitational forces? Which soil is transported by gravity? Loess, till, laterite, or talus? Next question was, which of the following type of soil remain at their place of formation? Aeolian soil, marine soil, residual soil, or colluvial soil? Okay. Many questions are interconnected, so you'll get one answer if you can answer another one. Which of the following processes may lead to disintegration of rocks? Which process may lead to disintegration of rock? Is it a chemical process or physical process or a biological process or all of these? A true false statement: soil transported and or formed by different processes are constantly subjected to further change by physical, chemical, or biological actions. Is it true or false? Which of the following processes leads to change in the structure of the rock and not its composition? Carbonation, hydrolysis, reduction, abrasion. Which process will lead to change in the structure without changing the composition of rock? Okay. Cohesionless soils are formed due to oxidation of rocks, leaching action of water, physical disintegration of rocks, or wind action. Cohesionless soil means soils like sand. Weathering process related to the activities of microorganisms is termed as geochemical weathering. Is it true or false? Uncemented deposits of minerals and or organic particles covering large portion of the earth's crust. What is it called? Rock, loam, soil, or aggregates. Alluvial deposits at the foot of hills or mountains is known as deltaic deposits, loess, estuarine deposits, or Piedmont deposits. The biggest size of clay particle is 0.003, 0.002, 0.0002, and 0.075. All are in millimeters. Silty clay indicates silt percentage is less than that of clay. Silt and clay particles are in equal proportion. Silt percentage is more than that of clay, or none of these. I hope after this many people have answered, were present during the class. If not, I will be discussing the rest of the answers because I need to give you some time to solve all these questions. Okay. So you can tell me like how much time you need to solve these questions. Should I start at 6:05? Anyone? Okay. You take some time to write down the answers. I will start at 6 o'clock. Okay. I'm giving you 10 minutes because these are just MCQ and MCQs mainly. There were no numericals. So I'll give you 10 minutes. I'll start the discussion session at 6 o'clock. Okay. I hope you have completed the answers by now. Shall we start discussing the answers? Hello, anyone? Saurabh, Himani, Wangchen. Have you completed the answers? Okay, we can start, right? Good. So, start with the discussion of the questions and their answers. All right. So, the first question was, what is the type of soil formed after deposition in the lake water? Any answers? Option number one, alluvial soil. No. Anyone else? It is very easy. It goes with the name only. Type of soil deposited in the lake water. It is lacustrine soil. Yes, someone. Yes, Imani. Lacustrine soil. It is lacustrine soil. Okay. Just a moment. Here, it is lacustrine soil. What is alluvial soil? Alluvial soil is those which is deposited by the action of river water. Alluvial soil, soil deposited by the action of river water. What is colluvial soil? Colluvial soil is deposited by the action of gravity, gravitational force. Okay. Any kind of soil which is deposited just because of the force of gravity on the surface of the earth is called colluvial soil. And other one is the marine soil. What is the marine soil? Marine soil is the soil which is deposited by the action of the sea water. Okay. So soil formed after deposition in the lake water. Deposition in the lake water is called lacustrine soil. Clear? Next question. So all of these are clear, I believe. Alluvial soil, river water, lacustrine soil, lake water, colluvial soil, gravity, and marine soil is sea water. Next question. A lacustrine deposit with alternate thin layers of silt and clay is called. Any answer? Any answer from your side for this question? Question number 2. You can tell the answer if you don't want to write. Or just
4 numbers, sir.
number 4, barved clay. Yes, barved clay is the right answer. Barved clay is the correct answer. It is the lacustrine deposit with alternate thin layers of clay and silt. But only the right answer will not help. You have to know what are the definition of the other three. What is loam? What is loam? Loam is a combination of barved clay. Loam is a combination of what? Loam is a combination of sand plus silt plus clay. Okay. What is muram? Muram is gravel plus red clay. Did anyone join the meeting right now? Gravel plus red clay. What is bentonite? Bentonite is volcanic ash after decomposition, or it is called decomposed volcanic ash. Okay, so lacustrine deposit with alternate thin layers of silt and clay. This is barred clay, absolutely correct. But loam is a combination of sand, silt, and clay. Muram is gravel with red clay. Bentonite is decomposed volcanic ash. Okay, this is the definition of this kind of soils. Okay, next question. Which of the following are formed by transportation by gravitational forces? Any answer? Any answer from your side? Soil transported by gravitational forces? Okay. Soil transported by gravitational forces, they are called colluvial soil, as I have mentioned previously. And a type of colluvial soil is talus. This is a type of colluvial soil, hence it is transported by the action of gravity. Okay. Now the others. What are the others? Loess is an aeolian soil that is transported by the action of wind. It's called aeolian soil. What is till? Till is transported by glaciers. This type of soil doesn't have a name. They are called glacier deposited soil, and till is one of them. What is laterite? Laterite is a residual soil. Now, what is residual soil? I think we have a question about residual soil. I'll explain at that time. Okay. So loess is an aeolian soil, till is glacier deposited soil, laterite is residual soil, talus is transported by gravitational forces, it is colluvial soil. Okay, I hope it is clear for all of you. What are the following? Which of the following are found by transportation by gravitational forces? The answer is talus. Okay. Next question. Which of
Excuse me, sir.
yes, yes. Okay. One by one at a time. Who is speaking? Yes.
Sir, repeat this question. Explain.
I I I I'll repeat the explanation of this question.
Yes, sir. Repeat
Yes.
this.
Yes. So what couldn't you understand? First tell me. This is a simple theoretical question. What couldn't you understand? Hello.
Sir, answer is explanation.
Answer is talus, because talus is a kind of colluvial soil and colluvial soil is transported by gravity. Okay, I mentioned na in the previous question, colluvial soil transported by gravity, marine soil by sea water, lacustrine soil lake water, alluvial soil river water. So colluvial soil and talus is a kind of colluvial soil. Okay, example, talus is an example of colluvial soil. Okay, clear?
Sir.
Okay,
Clear.
yeah, okay, good. Okay, so talus is transported by gravitational forces, right? Next question, which of the following type of soil remain at their place of formation? This is a very easy question. I hope you can give me the answer. Which of the following type of soil remain at their place of formation? Yes, Himani, residual soil, isn't it? Right. The soil which remains at their place of formation is residual soil, and example of that kind of soil is laterite. Okay, laterite is a kind of residual soil. Now, the others, you know, what are the agents of formation, agents of transportation? What is the agent of transportation for aeolian soil? Wind, right? What is the transportation agent for marine soil? Sea water. Residual soil at their place of formation, and I have mentioned already colluvial soil is gravity. Okay, so residual soil remain at their place of formation. Now, next question. Which of the following processes may lead to disintegration of rocks? What is the answer? Which of the following processes may lead to disintegration of rocks? What is the answer? All the three processes, whether it is chemical or physical or biological, may lead to disintegration of rocks. Action of chemical agents, any kind of acid or base, if they act on the surface of rocks, if they act with the rocks, they may cause disintegration and weathering of rocks. So chemical agents can cause disintegration of rocks. Physical action of force or pressure, external force on pressure on the surface of rocks may cause also disintegration in the rocks. So physical processes, physical agents can also cause disintegration of rocks. Biological, for example, any kinds of plants, the roots of the plant, when it penetrates, it may break through soft rocks, or any kind of microorganisms when they start uh, living in a particular place, they might secrete any kind of chemicals or enzymes which may cause disintegration of rocks, or the sheer what to say habitat of those organisms might cause weathering or disintegration of rocks. So all the three processes might lead to disintegration of rocks. So the answer will be all of these. Okay, all the processes of physical, chemical, and biological events may lead to the disintegration or weathering of rocks. Okay, all right. Next question. Soil transported and or formed by different processes are constantly subjected to further change by physical, chemical, or biological actions. Is this statement true or false? Please discuss this statement. I want you to tell me that a soil which is being transported once, okay, they are also subjected to further change. Is it possible, true or false? Anyone? After a soil is being transported, okay, by any, what to say, process or agent, then it is subjected to further change. True. Why it is true? Why it can be true? And how it can be true? It can be true because any particular type of soil, we don't know the history, how far or how many times that has been transported. For example, a soil might be, at some point of time, it might be alluvial soil deposited by the action of river. That soil might get dried up, okay, and stay there, and then over the years it might get what to say, solidified, and then it might form a different structure that might give a structure of residual type of rock or soil. In other terms, a soil might be transported by wind, okay, and where it is being transported, there is another agent, what to say, present, like the action of gravity. So aeolian soil might also get deposited further by the action of gravity. So once the soil is transported or formed by different processes, they can be further changed, or they can, their inherent properties can, is actually vulnerable. They can change by physical or chemical or biological action. So whatever I've said now is a what you say, physical action. Suppose the soil is transported by wind, and then where it is being transported is subject to the action of water. Okay, hydrolysis, breaking down in the presence of water. That's a chemical change. Or biological actions, the presence of microorganisms in the soil, they are constantly changing the nature of soil. Okay, so yes, after a soil is being formed, after a soil is being transported by one agent, it can be further subjected to change by another physical, chemical, or biological actions. Okay, so this is true, and this cycle goes on, like formation of soil, formation of rocks, rock cycle, then the breaking down of rocks to form soil again. The cycle goes on. Next question. Which of the following processes leads to change in the structure of the rock and not its composition? Change in structure only and not the composition, mind it. Any answer? Yes. Yes, Himani, good. Abrasion. Abrasion is a physical process. What is abrasion? Abrasion is the resistance to scratch. Abrasive value of any material is the resistance to scratch on the surface. That is a physical change. A scratch on the surface is a physical change. Whatever the other options are, carbonation, hydrolysis, reduction, these are chemical processes. Carbonation, addition of carbon dioxide or carbonic acid in the presence of carbon dioxide. Hydrolysis, breaking down in the presence of in the action of water. Reduction, reaction, addition of hydrogen ions. I think that is the reduction process, or removal of oxygen. So the other three, carbonation, hydrolysis, reduction, these are chemical process. What is the chemical processes which leads to the change in the chemical structure or the chemical composition of the rock. The composition of the rock, it changes, and this is important because when a soil is formed from the disintegration of rock, that kind of disintegration can be physical or chemical or biological. So if it is simple abrasion, then one type of rock will be formed. If it is simply reduction or reduction and hydrolysis, then also one type of soil will be formed. And if it is only carbonation, another type of soil will be formed. So the type of disintegration process of the rock decides the type of soil which is being produced, is being made from the parent rock. Okay, so in this case, this process of abrasion, it leads to only change in the structure of the rock, physical structure, not its composition. Okay, this is a physical process. Okay, next question. Cohesionless soils are formed due to cohesionless soils are formed due to. Any answer? Cohesionless soils are formed due to, see, cohesionless soils are formed due to physical action on rocks. So that might be wind action or physical disintegration of rocks. But because of wind, it is only transported. Wind action is a transporting agent. Only wind cannot cause disintegration of rocks if it is not too strong a wind or something like that. So physical disintegration of rocks is a general term utilized to say that the physical structure of the rock has changed, and that has led to the formation of cohesionless soils. Soils which do not have any cohesive force between its own particles. The rest, oxidation of rocks, it is a chemical process. Leaching action of water on rocks is also a chemical process. Physical change leads to the formation of cohesionless soils which do not have cohesion, for example, sand and gravels, and that is formed by physical disintegration of the rocks. Clear? Next question. Another true false question. It's very easy. Weathering process related to the activities of microorganisms is termed as geochemical weathering. Is it geochemical weathering? Anyone? Any answer? Weathering by microorganisms. Is it called geochemical weathering? Very easy. Okay, no answers. Yes, Himani, false. Then what is it called? If it is false, then what is it called? Because of microorganisms, any kind of disintegration, if it is happening, then what will it be called? Any process where life is involved, that is the action of organisms are involved, it is called biological weathering. Okay, so weathering process due to the activities of microorganisms is termed as chemical weathering. It is false. It is called as biological weathering, and not even biochemical, because it is, I have written the weathering process of microorganisms. If it becomes more and more specific, like the weathering process because of the chemical action on the rock happening due to microorganisms present in the rock, that might be termed as biochemical engineering or something like that. But this is a general question, so it will be only biological weathering. Okay, so this is a false statement. Clear? To the next question. Uncemented deposits of mineral and or organic particles covering large portion of the earth's crust is called. What is the answer? Any answer, anyone? Uncemented deposits of mineral and or organic particles covering large portion of the earth's crust is called. Soil. Yes, Simani is giving all the answers. Soil. This is the basic and general layman definition of soil. In engineering terms, uncemented deposits of mineral and or organic particles covering large portion of the earth. Why mineral? Because soil might be formed from rocks. Okay, and rock is an aggregate of minerals. So it is an uncemented deposits of minerals. If it is cemented, if it is cemented, it becomes it becomes rock. Okay, so it is uncemented means it is soil and or organic particles. Soil may also be formed from organic particles, decay and disintegration of organic matter. Okay, so in both the cases, what is formed? The covering of the earth's crust known as soil. The rest of the options, rock, then aggregate of minerals which form soil. Loam is a kind of soil which I have already mentioned, and aggregates, these are classification of soil. This is a type of soil, fine aggregate, coarse aggregate, mainly used for building purposes. Okay. Alluvial deposits at foot of hills or mountains, they are called. Any answer? Alluvial deposits at the foot of hills or mountains. Okay, this is called Piedmont deposits. Okay, Piedmont deposits. Deltaic deposits, deposits at the river mouths, which results in an extension of the shoreline. Deltaic means deposits at the river mouths. Loess is a kind of soil I've already mentioned, and estuarine deposits, mixed deposit of marine and alluvial. So estuarine is a mixed deposit of marine plus alluvial. Obviously, the name suggests estuarine means at the estuaries, joining of the river and the seas. So there will be, that will be the location for the estuarine deposits, and Piedmont deposits found at the foot of hills or mountains. Okay, so this covers the origin of soil. Now the next section is the classification of soil. Okay, this is a separate section. The first question was the biggest size of a clay particle. Any answer? Biggest size of clay particle. Any answer? Okay, so the biggest size of clay particle is 0.002 millimeter, or in other words, it is 2 micron. Okay, the size of a clay particle ranges from 0.002 millimeter and below. Above this, up to 0.075 mm, that is 75 microns, it is silt. Above this comes the coarse grained soil, sand and gravels. 4.75 mm. If it is more than that, then it is gravel. Up till 4.75, it is sand. Okay, so this is the answer: 0.02 mm or 2 microns, biggest size of clay particle. Next question: silty clay indicates. What does the nomenclature silty clay indicate? Any answer? Silty clay, it indicates that silt percentage is less than that of clay. Okay, because when we are having a fine grained soil or a coarse grained soil, the the percentage, the fraction which is less in amount, that comes as a descriptive term at the beginning. Like the sample is clay, but since it has silt also present over there, it is silty clay. But the main sample is clay. Okay, the main sample is clay, but since silt is present, it is clay. If silt percentage is more than the clay, it might be clay silt, because the main soil sample is composed of silt, and with the silt, clay is also present. Okay, so when silty clay, we always know the first thing which comes in the term, it is less in amount, then the second thing is more in amount. So silt percentage less than clay, that means it is silty clay. Okay. Next question: BIS soil classification is based on. I think you can give the answer. Anyone? BIS soil classification is based on. Okay. It is based on grain size distribution and also the plasticity properties. So both of the above. We will be getting to know this concept in detail in the upcoming questions. Okay, how BIS soil classification is based on the both the grain size distribution and the plasticity properties. Okay, so it is both. Okay. Okay, so there is a power cut. I believe I will just shut down the. Yes. Okay, so boundary classification. Boundary classification is to be resorted to for coarse grained soils when the percentage fines is. Any answer? Is the PPT visible, right? And I'm audible. Saurav, Himani. Hello? Are you there? Yes, okay. There's a power cut. If there's any disruption in the network, don't leave the meeting. I'll be joining right back. Okay. Boundary classification is to be resorted for coarse grained soil, and the percentage of fines is okay. So suppose the coarse grained soil is gravel, then if it is less than 5%, then we will not incorporate the percentage fines. It will be either well graded gravel or poorly graded gravel. Okay, I'll not write that one here. Just a moment. Yeah. So when it is less than 5%, then we will not incorporate the percentage fines. Okay, so it will be either well graded gravel or poorly graded gravel. That's it. If it is greater than 12%, then we will be incorporating the percentage fines. Okay, then if the sample has clay, then we can call it clayey gravel. The sample has silt, we can call it silty gravel. It is more than 12%. But boundary classification means you have to incorporate both of these, and that comes here. Well graded silty gravel, like this. Clear? So that is something which is very important to know for the classification system as per the Indian standard. So boundary classification means you have to incorporate both the fine percentage of fines and the type of soil and the gradation of soil, well graded, poorly graded, uniformly graded. That is when the percentage of fines lies between 5% and 12%. So this is the right answer. Okay. Next question. Among the given soils, the specific surface is the highest for. Okay, this is a very interesting question to discuss, and this has many what to say. This is much significant in as per the engineering properties of soil. So, which of this has the highest specific surface? Any answer? Clay. Yes. Why clay? What is the reason for clay having the highest specific surface among all these kind of soils? What is the reason behind this? It has more surface area. That's the thing. Why it has more surface area? Surface area, not surface area. And because surface area per unit mass, fine particle. Yes, Wang Cheng is heading towards the right direction. Fine particles. Good. It has more surface area per unit mass because it has finer particles. Or if I say that I'm comparing these four types of soil: sand, silt, gravel and clay. Gravel is the coarsest ones and the size decreases from gravel to sand to silt and clay. So gravel is the having the maximum size. Okay, gravel maximum size, then comes sand, then comes silt. I'll just write like this with the actual symbol. Then comes sand, then comes silt, then comes clay. So clay has the minimum size of particles. So in a particular mass of soil, suppose it is 1 gram. Okay, it is 1 gram. 1 gram, if the mass is constant for all this kind of soil, then clay will have the largest number of particles because it has finest particles. So more the number of particles present over there, more is the number of area associated with the particles, and hence more is the surface area. So as I've said, specific surface is equal to surface area per unit mass. So if mass is constant, the surface area is more, then the specific surface will also be higher. Hence, clay is the soil which has a highest specific surface among all these kind of soils. Is it clear, everyone? If it is not clear, I can repeat once. You can tell me, and if it is clear, I'll just move on to the next question. Because this is a conceptual question. Yeah, okay, Himani, thanks. Okay, so next question. The soils which plot above the A line in the plasticity chart. This is a very easy question. You can see this is the plasticity chart and this is the A line. It has the equation plasticity index IP is equal to 0.73 into liquid limit minus 20. So above the A line you can see over here we have Cl, Ci, Ch. This is clay. We don't have O. O we have below the A line over here MlNOl, MlNMiNOI. O means organic, and if it is not O, it is inorganic. So below the A line we have organic COH, and also below the A line we have M. M means silt, and above the A line we have clay. So soil particles which are above the A line, we can say in a generalized sense that that particular soil is inorganic clay. Isn't it? It is inorganic clay because silts are below the A line. Organic clay is not present over here because it will be CO, and CO is not mentioned anywhere in the plasticity chart. Okay, organic soil, everything below the A line is organic soil. Organic soils of high plasticity, silt, high plasticity. Organic soils of intimate plasticity, silt, intimate plasticity. Organic soils of low plasticity, silt, low plasticity. Okay, so anything above the A line is inorganic clay. Okay, next question, another question of the plasticity chart. Soil has a liquid limit of 20% and plastic limit of 14%. Anyone has solved this question? Soil having a liquid limit of 20% and a plastic limit of 14%. Has anyone solved this question? Numerical? Alright. No worries. So a liquid limit of 20%, plastic limit of 14%. Liquid limit, that is, I'll say WL, it is 20, and what is the plasticity index? It is liquid limit minus plastic limit, it is 6, right? 20 minus 14 is 6. So 20 on the x-axis and 6 on the y-axis. Before that, I'll tell you that this is Cl and Ml, clay of low plasticity and silt of low plasticity. This region, shaded portion, this ranges from 4 plasticity index to 7 plasticity index. Okay, and this is the line of 20 liquid limit. So it falls somewhere around here. So the soil is inorganic clay and silt of low plasticity. Why inorganic? Because it is lying above the A line. Below the A line it is organic. Above the A line is inorganic. So it is inorganic. Silt and clay. See, silt means M and clay means C. So both silt and clay are present over here, and of low plasticity because we have L written over here. Clay of low plasticity and silt of low plasticity. So it is this, it is falling in this shaded region. So the answer is option C, inorganic clays and silt of low plasticity. I hope it's clear. So this chart, plasticity chart, is very important for everyone to understand how the classification is made as per the IS classification system, as per the grain size distribution and the plasticity. In it is basically, this chart is basically for the fine grain soil, because you can see over here we have C and M, that is clay and silt. It is only for the fine grain soil. Okay. All right. Next question. If a soil retained on 75 micron sieve is more than 50%, the soil is fine grained. Is it true or false? Now you tell me this answer. Soil retained on 75 micron sieve, it is more than 50%. The soil is fine grained or coarse grained? True or false? Yes. Raised your hand. Who raised their hand? Himani. True. Which particle has largest size of 75 micron? Largest size of 75 micron. Like I've said, largest size of clay is 2 micron. So largest size of which particle is 75 micron? Silt, right? 0.075 mm. If this largest size of silt, the largest size of silt is 75 micron, and I am saying over here that more than 50% have been retained on 75 micron sieve. That is, more than 50% of the soil sample is larger than 75 micron size. So is it fine grained or coarse grained? What is the barrier for fine grained and coarse grained soil? Which size is the barrier? 75 microns, right? Beyond 75 microns, up till 4.75 mm is sand. Beyond that, it is gravel. I think up to 80 mm. Yes. So if 75 micron is the boundary deciding the fine grained soil and coarse grained soil on both the sides, then if it is retained, yes, one thing, coarse grained soil. If more than 50% retained in 75 micron sieve, that means it is more than the size of 75 micron. That means the soil is coarse grained soil. Okay. Good. So this is, the soil is fine grained. This is false. Okay. The statement is false. I hope it is clear. Yes. Next question. A soil has a liquid limit of 30%. The corresponding plasticity index given by the A line is. Any answer? Soil has a liquid limit of 30%. Plasticity index given by the A line. What is the equation of plasticity index as per the A line? (0.73) WL minus 20, right? WL is the liquid limit. 30 minus 20 is 10. 0.73 into 10. It gives us 7.3. Okay. So the answer is the third option, 7.3. This equation is also very important to remember for this kind of numericals, because this is the line classifying the or distinguishing the organic from the inorganic soils. Okay. What is Z? Where is Z? It is not Z, it is 7. This is not Z, this is IP. This is IP. Okay. You follow this equation, IP equal to 0.73. Yes, so is it? WLZ, WL not Z, it was minus 20. I'll just tell you. IP equal to 0.73. WL is the liquid limit minus 20. WL minus 20. WL minus 20. WL is 30 minus 20 is 10. 0.73 to 10 gives us 7.3. Clear? Is it clear, Himani? Is it clear now? Hello?
Yes, sir.
Okay, I saw your message. Yeah, okay. So this is the third option is the answer. Okay, last question. Group index of soil ranges such that. What is the answer? What is group index? The range of group index. Okay. So group index, what is the formula for group index? Group index is given by the Highway Research Board. This is the Highway Research Board classification. Someone give the answer. Someone wants to join. Okay, Sarvesh, you have joined late. The session had already begun from 5. It is on the verge of ending. You can see the video on YouTube. It will be uploaded today. Okay, so group index, the formula for group index is 0.2a plus 0.005 0.005 AC plus 0.01 BD. What is A, B, C and D? This is A and B. These are percentage passing through 75 microns. A is more than 35 to less than 75. That means A will have a value from 0 to 40. Okay. Okay, 0 to 40. And B will be more than 15 to less than 55. B will be having a value of also 0 to 40. You can all find this thing in a standard textbook of soil mechanics. B.C. Punmiya, Gopal Ranjan Rao, anyone. What is C? C is the liquid limit. Liquid limit more than 40 to less than 60%. So C will also range from C will range from 0 to 20. Okay, 20. Notice D. D is the plasticity index. This will also be ranging more than 10 to less than 30. It means it will be 0 to 20, the range. So if you all put the minimum range over here and the maximum range over here, you will see it lies between 0 and 20, including the values. Because if you put 0 in all the values in A, B, C and D, you get the value of 0. So group index can have the value of 0 and group index also can have the value of 20. So it falls between 0 and 20, including the values of 0 and 20. Okay, clear? Okay, any doubts regarding the session? Anyone having any doubt regarding the session?
No doubt, sir.
Okay, so I hope it was clear. The answers and the concepts are clear. Okay, then I'm going to end the meeting and we will meet next Sunday at 5 p.m. Prerequisites for next. I believe the classes, your course is going on right now, right? I think this is the syllabus. So origin of soil and classification have been done. Okay, next week it is a three-phase diagram and weight volume relationship. Okay, it is like no need to like study everything and come. It is not a exam. Just come. I'll just give you some questions. Make the session a kind of interactive one. Give the answers, explain the concepts from your side also, so that everyone can learn. Okay, so yes, three-phase diagram and weight volume relationship will be the next day's topic. It will include the index properties of soils. Okay, index properties and some what to say testing like grain size distribution and all those things. It will also include. Okay, so just make this session interactive and answer the questions along with give the concept whichever you know. Okay, so that everyone can be benefited. All right, if there is no other questions, then I will just end the meeting. Okay, bye bye.